All right. Thank you, everyone. Good afternoon, and thank you for joining this session. I'm Samiul Hasan. I'm an assistant professor at Civil Environment Construction Engineering Department at UCF, and I'm also affiliated with UCF's Future City Initiative. So today I'm going to talk about how data science can be harnessed to build more smarter and more resilient cities. So first, a little bit of myself. I graduated from Purdue University in Transportation Engineering in 2013, and then I did a postdoc at UCF's CSRO Cities program from 2013 to 16, and then I joined at UCF from 2016 fall as an assistant professor. My research interests are mainly from urban data science, human mobility, and transportation network modeling. I'm also interested to learn infrastructure interdependency issues, disaster management, and hurricane evacuation problems. Currently, I'm involved with two initiatives at UCF, UCF's Future City Initiative, organized by CEC Department, and Urban Resilience Initiative by UCF Public Administration Department. Some of the achievements that I have got so far, I have 4 NSF projects, and 2 of my students got outstanding MS thesis award from CEC's department. In terms of teaching, I'm now teaching 2 undergraduate courses and 2 new graduate courses involving data science and emerging data sets. I'm also the associate editor of 3 journals related to natural hazards, big data analytics in transportation, and frontiers in built environment. So let me give you a very brief overview of my research. So we have embedded lots of sensors and devices in our built environment, and we are beginning to get lots of real-time streaming data, starting from traffic signal to connected and autonomous vehicles. So with this type of data, what we are trying to do is that create new analytics and building new insights or providing new insights to our city managers. So in this talk, I'm going to talk 3 specific projects where we harness data science and emerging data sets to understand infrastructure disruptions, delivering critical services during a hurricane. We want to improve real-time emergency response, and then how we can improve urban mobility and congestion analysis. So first, let's look at one of the projects that's funded by NSF. The project idea was to predict real-time population behavior using transportation system and social media data. This is a project that I'm the lead PI and collaboration between UCF and Tulane University. In this project, what we wanted to do is to develop novel information fusion method that we can merge social media data and survey data, so that we can get a more representative sample of user preferences and expected behavior during a hurricane. And another objective is to create real-time applications of emergency response, such as predicting hurricane evacuation traffic. So in terms of this one, if you look at the right figure where we can recreate the traffic congestion pattern during Hurricane Irma. So the Hurricane Irma has an interesting story. During the beginning, it was supposed to hit from the eastern side. But then as the hurricane is progressing, it shifted its path near, September 6, 7, 8, we have a lot of traffic movement northbound, but as the hurricane was moving, it shifted its path coming from the eastern to the western side. And then we have collected lots of data from different detectors on Floridas, and then we find out that recreate the story that near hurricane landfall, near September 9, we have a lot of traffic movement towards eastbound. Now, what can we do with this type of data? We can develop a model that can predict evacuation traffic flow patterns. And what we did here in this research that we developed a deep learning model. We feed the model with the dynamic graphs of all those snapshots of traffic prediction, and then also added some new node level features so that how far they are from the coast and the population in each of those areas. Now, with this type of information, we could predict of all the 800 detectors that we have collected data for. This is a massive scale data, and we could predict traffic very accurately. And we could do this for 1 hour prediction horizon to 6 hour prediction horizon. Now, this is an incredibly important application for transportation management agencies, because they want to know how they want to act when they want to activate shoulder uses or different types of strategies so that they can manage the traffic in real time. So that is one of the things that we have done with this project. And I'm going to show another project. The story before the landfall was about hurricane evacuation, but the story gets much more difficult when after the landfall. So in this project, we're going to look into the resilience of interdependent infrastructure systems after a hurricane made its landfall. This is a joint project over 7 universities, and UCF is also a part of the team. In this project, we want to investigate the effects of hurricanes once they made a landfall in the interdependent infrastructure systems, for example, energy, water, transportation, and telecom. I want to also understand household and community behavior during hurricanes. And our goal is to develop some complementary pathways for enhancing coastal resilience. So what I mean by that is that there are like 5 interdependent tasks. And my task was basically focusing on developing the social infrastructure systems. And developing that type of systems requires lots of data about infrastructure disruptions, about human behavior. And it is a very challenging problem because during hurricanes, you don't have lots of sensors embedded in different parts. So we have to collect the data. So what we did was that we collected data from social media platforms such as Twitter. And from Twitter, we collected the tweets made during Hurricane Irma, and we tried to build a machine learning model that can infer what type of infrastructure disruptions occur during that period. And we can develop a model that have predicted 7 types of infrastructure disruptions. For example, what you can see here, that as the hurricane is going over towards the inland, we can have more tweets related to power outage. At the same time, we can also have disruptions related to drinking water. So that was one of the very interesting application for emergency management agencies, because they can now use this type of real-time prediction or real-time assessment of infrastructure disruption so that they can develop some emergency response strategies. So this is one of the good applications where we can develop social sensor data to understand infrastructure disruptions in real time. Now I'm going to switch the gear a bit to talk about specifically another applications that we developed for Florida Department of Transportation. In this model, we developed a high fidelity traffic forecasting model for transportation application. So what we did here is that we built a machine learning model collecting high fidelity traffic data, sensor data from all the intersections in a county, and also merge this data with traditional data sets like link capacity, socioeconomic, and land use data. And also develop a data pipeline and build a traffic visualization platform. So the challenge here is that this may be familiar to you that we have, this is UCF, this is very close to UCF. So this is UCF here near Alafaya and Macula Group. And we have collected data of near 300 intersections in Seminole County. And with that data is from automated signal performance measures. So it records every event in a traffic signal in second by second. So with that data, we build a machine learning or deep learning model of nearly 200 intersections in Seminole County. We train the model with 2016 data, and then we try to test that how this model is predicting traffic. So the challenge here is that we want to predict traffic at a very high resolution, especially like whether the traffic is moving northbound or southbound and direction wise, and also what the traffic would look like in a weekday and weekend. So we build this platform and try to show traffic managers, and we demonstrate that the traffic can be very well predicted 3 years down the line. So what we are doing here with this, for the 200 intersection, we can predict traffic for the 2023. So now we have a projection year 2023. So we're going to very quickly launch this platform with Florida Department of Transportation. So that is an application of data science for developing smart cities. So in terms of the future research and collaboration, I'm also involved with 2 current projects. One is NSF Smart and Connected Communities, where we are looking at social media data for understanding how emergency management agencies communicate risk during a hurricane. I'm also looking at a strengthening American infrastructure project where we look into adaptive infrastructure management issues during a rapidly intensifying hurricane, such as Hurricane Ida. In long term, I have proposed a data-centric convergent platform for assessing resilience and recovery of disrupted social infrastructure systems. So this is part of my NSF career proposal. I'm also interested to look at emerging technologies and data science for transportation applications. So mainly I'm looking for collaborations in connected and autonomous vehicles research, smart and connected community, and folks working with emergency management. And also if you are working in the, deep learning architecture, what we can use for transportation and resilience applications. So This is a bit of acknowledgement to my lab members. So you have 3 new members and 2 of my graduate students who have graduated recently, Komor Roy and Rizal Rahman. Both of them have joined as a senior data scientist position in the US. And I also thank my collaborators from many different departments and funding agencies from NSF, Florida DOT, and SafeRSIM. And we also have data partnerships with Twitter, Facebook, and SafeGraph. So I would also like to thank all of them. So with that, I want to end. And if you have any question, I'll be happy to answer them.